to our video interview. Our guest today is expert in modeling, Dr. Yuri Balasanov. Yuri has several hobbies. He is a professor at the University of Chicago, where he is teaching advanced analytic courses. And he is a chief data officer in a trading company in Chicago. His second hobby is singing. Yuri sings with Northwestern University Choir. So today is the last week of 2022, and we decided to review our discussion about modeling, which we done 5 years ago. We talk about our experience in applying modeling technology to optimize business and IT decisions. We talk about our expectations in increasing role of applying advanced analytics in business and IT. And during our discussion, Yuri, if you remember, you mentioned that many methods of artificial intelligence technology existed for a long time, including deep learning, driverless cars. You mentioned computers playing games for sometimes, and we have a lot of successes, like, for example, beating Garry Kasparov. And we are realizing right now that a lot of things which we thought are not so important, but now it's becoming important. For example, increasing acceptance of TensorFlow and artificial intelligence. This is you mentioned last time, right?
Yes.
Yeah. Okay. And it was your idea that world is changing continuously, but it's changing so fast that it seems like we're making a lot of jumps. You also mentioned that the model which were built in 19th century by German mathematician and physicist Gauss. Now, and he spent a lot of time building this model, now this type of model can be implemented by using neural networks just in a few minutes. You just select enough depth in your model, and you use AI neural networks, and everything done in no time. And it was your example, and we look at what's going on with autonomous cars driving on the street, or looking at work in a factory, or watch robotics. Inside all of these devices, we can find neural networks. This is what we discussed last time. And we also talked that building mechanism for self-driving cars is very tedious. A lot of things should be done. But it was your thought that actually applying artificial intelligence, especially for vision recognition, a lot more impressive rather than just supporting, let's say, decision support optimization. So if you look what we discussed 5 years, okay, especially progress with artificial intelligence, one of the thought was, well, we have to really process a lot more data and a lot faster to control moving cars, etc. And this is a role of cloud computing. On using cloud computing, we can really absorb a lot of data in real time, operate with this data. And this is what we discussed last time. What are your thoughts? So what changed in 5 years? Are we on target? We were right? Or what really different? Okay, what do you think?
Great conversation, Boris. First of all, thank you for having me. I'm delighted to discuss this again after a 5-year period. What we discussed last time, and you gave an accurate summary of what we talked about. Last time, it seemed like it is a near future. It was happening already with us, but it still seemed like it will happen very soon. And today we can say it has happened. Maybe not everything that we imagined, but a lot more that we imagined then has been developing beyond our imagination. For example, with neural networks, I can feel it by how I teach students. In the last 3 years, I had to rewrite my courses completely because what seemed to be the edge last time is now may sometimes even not have space in my course because so many different ideas and different methods have appeared that some less important stuff that seemed on the edge last time has to be pushed out. Also, last time we talked about something that's happening that's what was very exciting, like using artificial intelligence for playing Atari games. Today, it is already in our real life. There was a very recent article in The Economist that was titled, let me just read you the title of that. Artificial intelligence is permeating business at last. And it started with John Deere sending the first fleet of driverless tractors to farmers. So this is now a reality of everyday life. And what's interesting that's happening in this process, as soon as it becomes so practical and real, it becomes not cool. And in that article, there was also somebody quoted saying, as soon as it becomes a real application, we stop calling it artificial intelligence. It's just the algorithm that keeps working. That shows how quickly our minds transition from dreaming about it to actually having it implemented in practice and not paying attention as something cool anymore. That's really still mind-boggling. And we have several revolutions during this period that occurred. One of them, of course, is in the area of natural language processing. So last time, that was something that we talked about, the computer vision. Computer vision revolution happened around 2014. What was that revolution? The team at Google, they used huge model that you and I couldn't run on our local computers or even in a reasonable cloud because it really literally costs billions of dollars. So they trained this model on computer vision, on different images, everything they could find on the internet. And that computer vision model, was able to understand the images very well, so that when you need some specific task, you take this pre-trained model, and Google made it public, open source. You take this pre-trained model that has already huge knowledge about all kinds of images out there, and tune it a little bit more for your own task, and bang, you have a model. You don't need to train it yourself. You only need to tune it up a little bit. So that was in 2014. So that already had happened at the time when we talked last time. Today, the same similar revolution happened in natural language processing. 2019, 2020, those were the years when something dramatic happened in natural language processing. Same idea. There was a huge model trained on a lot of information. Wikipedia is not enough anymore. It has to be everything that is out there on the internet, scraped and then cleaned and prepared. And then you train your huge model, again with the same enormous cost that only big tech could afford. And then they open up this model as an open source, and you can download this model. You still need to do it in cloud because it requires resources, of course. And then you supply it with maybe one additional layer in a neural network that does specific tasks that you want to do. For example, you want to classify whether the text belongs to your sphere of interest or not. That one additional layer with few parameters you need to train, and then all together with the pre-trained model, you tune one more time with a couple epochs, and again you have very powerful model.
If you want to train your model not in English but in German, you have to retrain everything from scratch. Is it right?
There is a pre-trained model in German too.
So you have to do it separately for each language.
You have to do it separately, except for models that are specifically designed for translation. Then there are trained models for translation from one language into another language. There is a variety of these models. They have similar structure, architecture, and they are pre-trained. That's the most important thing. It would have taken us months and months, maybe years, and a lot of money to train these models ourselves. But now they are available off the shelf.
And very challenging. You have to find your own data.
Exactly.
And sharing data, this is the huge benefit.
Oh, exactly. You're right, because we know a lot about how Google makes money. I'm quoting here Professor Ng. He said once in one of his lectures or interviews, we know pretty much how Google makes money, but it doesn't mean that we can repeat and reproduce their business because they have data capital. So that data capital is a very important component of training the model. And what is in the pre-trained model, that data capital has already been used for training, and it's available to us in the form of this pre-trained model that understands language at the level, and the authors of the models actually claim beyond the level of human ability to understand the language. And this gives you immediately very broad spectrum of applications. And everybody today is talking about Lambda, the chatbot developed at Google, or ChatGPT that was developed by OpenAI. These models are now available. A couple of weeks ago, I had my first interaction and chat with ChatGPT. And this model talks to you like another human can talk. So this is huge progress. In the matter of 2-3 years, it is a huge progress that still will need to find its way to everyday's life, but that will be much shorter every time we come through this iteration of going from individually designed and trained models to pre-trained big model that then opened up as an open source, and you can adjust it a little bit for your own needs, and you have quick way of using very powerful model with millions and millions of parameters, something unheard of for models of 19th century. And you have them available with enough computing power. That's where we start talking about doing it in the cloud. I do have pretty good equipment here at home because this is my profession, but for something like using BERT model for natural language processing, of course, I will need to go to the cloud, not only because it's so expensive, but also the lifespan of this servers is not that long. In cloud, I can always use the newest, the most powerful server. It's like leasing a car rather than buying it. You always drive new car. With the cars, you don't always have to drive new car, but with these servers, you do have to stay on top because the software always assumes that you have enough computing power to use the new models. That's what's going on now. We're talking not about the future anymore, but it has happened, and it has happened in the traditional industries like John Deere manufacturing the tractors for farmers.
This is a great example, very impressive illustration about the power of artificial intelligence and from John Deere. But if you look overall, spectrum of different modeling technique companies use, not only artificial intelligence, but machine learning, simulation, Q network models, and other models. Okay, what do you see in this area? What kind of changes you expect, and application different type of models for solving business problems and optimizing IT decisions?
That's a very interesting question you're asking. First, let me give you not maybe an answer that you're expecting. What I see is the process of changing names. What used to be statistical analysis, then at some point became data mining, then at some point it became machine learning, then at some point it became artificial intelligence, and we're already looking for the next name beyond artificial intelligence. So we're talking about something.
By the way, artificial intelligence not necessarily right representation of what we do.
Absolutely
I
not.
agree. Yeah,
And that's the key.
I think it's a wrong name.
Exactly. I noticed this pattern. This is something still data science. Let's call it data science because it's encompassing all. But it is data science evolving, and as we get to the new level, we start dreaming about the next, and we give the name that corresponds to something that we cannot do yet, but will do next time. So machine learning, that name appeared, for example, at the end of the 20th century. We still used logistic regression and linear model mostly. So how much does machine learn when you fit logistic regression? Not much. But we wanted to think about one day when the model will learn itself, or computer will learn itself, and we'll be able to predict without us interfering. So by now, what we call artificial intelligence may be called machine learning. But artificial intelligence is the next step that we still trying to do, but not to the perfect level, and we call it artificial intelligence. So something will come next. I don't know exactly which name will be adopted, but definitely what we see is a quick turnaround and changing the same data science in evolution with the new names, giving it the new names. And that reflects our progress. That reflects also, it's kind of a demographic process. New people get involved, community grows exponentially. And when community grows, it always brings the question, who are we and what are we doing now? And that's why there is a need for revision of the old model. We don't want to do anything with statistical analysis anymore. And I'm part of that community, and I agree with that. But we give it new name, and then in a few years, we finally learned what we tried to do when we gave this name, and it's time for a new name for that.
So what do you think about simulation models, network models, the applications and progress? Let me give you an example. Why I'm asking it. Because when we try to apply artificial intelligence or machine learning algorithms to optimize, let's say, IT decisions, let's say related to multi-cloud environment. Okay, in certain cases, when we would like to evaluate different scenarios, we don't have data collected to train the model to evaluate certain what-if questions, which didn't happen before. So if you don't have data to train your model, you cannot answer this type of questions. And this is why we use network models. Some people use simulation models. So what do you think about that? Limitation of AI and potentially using other modeling technique to address specific problems in business and IT.
Yeah, that's a great point. I think it's not a limitation of AI, but it's a pointer to a direction in which AI will go next. Here's what the problem is. First of all, when we talk about AI in application to the real businesses and real industries, we need to recognize that we created a monster. That AI is a monster that needs to be fed with enormous amount of data. And so in order to extract any value from AI, any business, any industry, and we have plenty of examples now, they have to go through a digital transformation process. Digital transformation process means that we have to organize the flow of data, the flow of information that will never be interrupted by humans. It has to be completely different setup. It's not just putting more efforts in building new IT. It's not just IT. IT is very important in building the infrastructure, but it is important to organize the flow of information so that human is nowhere in the middle of this flow. Only in that case, we can organize, like in that example with John Deere, every tractor, whether it's driverless or still has a driver, contains thousands of different sensors. these sensors constantly sending information to John Deere, and that's how John Deere collects the data capital. So in order to process all this, you have to smoothly redirect all this information from all the sensors through the validation and wrangling. You need to understand if the sensor that sends you information is still working properly, or it's already not working and sends you something that's not useful. Sending information to the tractor if the sensor is not working properly to try to fix it or try to organize the maintenance. And then you collect this, aggregate this in a form that can be fed into artificial intelligence for making decisions. That's where we come to the biggest difference between machine learning and what we now try to call artificial intelligence. Decision making is not exactly equivalent to forecasting or predicting.
So you think that artificial intelligence technology will replace simulation and analytical neural network models?
No, not necessarily. Not necessarily. The new approaches appear. It doesn't mean that old approaches have to go. We still use linear model that Gauss created in 1811. Still use it, and it's still providing us with very important insights. It's just understanding that it's not enough to solve every problem out there. But yes, for the main problem that this monster called artificial intelligence now beginning to show is that we have so much data and we're so excited about this data, if not fixated on the data, that we now live in the data-centric world. Data-centric world is very dangerous. Let me explain you why I think that. If you have never seen something in the data, that doesn't exist for you. If you're data-centric, you have no chance to predict black swan events. That means that you need to now put in your process, in your artificial intelligence decision-making engine, you need to put data where data will be available or are available now, and input from some expert. It was easier to do in old times when you had some small data and the process included manual intervention by humans. Now you have to organize this process so it happens without intervention. And machine learning, as we defined it as model for predicting, taking data and predicting automatically. That
based on model which trained on previously collected data.
Exactly, right.
What if data not available?
Exactly. So first, now you need to shift your attention from prediction to decision making. And decision making requires not only collecting the data, but using this data together with some expert opinion. And we have new models, new approaches. Bayesian networks is a very hot topic now that allows you to combine seamlessly the information coming from the data with information which is completely hypothetical. We may not have seen any event like that, but there are people who can imagine what will happen if that event or the other event occurs. Combining them together is a very important topic today, and I'm sure next time if we talk about this, that is already will be in the past, and will stop being cool, like everything else that we're talking about.
Yeah, a lot of people working on that. We try to use analytical neural network models to answer different what if questions and generate data answering the questions about events which didn't happen before, and expand data set by not only measured data, by predicted data using other modeling technique, and then retrain model, and then use this AI model to answer very specific questions we're interested in. But it's too tedious. We didn't achieve good results yet. But,
that's exactly true. Yes, I see a lot of interest to using new well, it has been around, but now I see a lot of interest to using this model in the new new decision-making engines, which is based on Bayesian networks. That's where it's ideal construction for root cause analysis. You set your scenario, or you set what your observation is, because you may be observing only partial information, and it tells you probability of what else will be happening with different parts of complex systems.
Very interesting. Very interesting. But if you think about your business experience, okay, can you give us some examples where you discover limitations of artificial intelligence, where progress should be made in terms of developing new technology? In other words, can you describe a couple of failures or limitations where industry should work on in order to make AI more effective?
I can try, yes. One of them is related to spurious correlations. It's again related to the data-centric world. We're so excited about more data collected and more data providing us with information that we sometimes forget that data-centric will have a limitation of seeing only what's in the data. So spurious correlations, how to explain this concept? If you, for example, take some variable that you would like to predict, let's say it will be the time until some engine malfunctions, or it might be predicting the price of some asset in financial market. If you take completely random predictor for it and simulate it many times, very soon in a limited number of your simulations, you will find completely irrelevant predictor that will have very high correlation with a variable that you are trying to predict. This is called spurious correlation as opposed to causality. Causality means that the variable that you use for prediction has some explanatory power and actually influences the variable that you want to predict. Spurious correlation is a strong statistical relationship that doesn't have that causality. So what happens if your machine learning or artificial intelligence model starts predicting based on this spurious correlation? The model may work for some time very well, and then all of a sudden you don't know why and you don't know when it stops working. There are plenty of examples of such models in Google's experience, in the experience of many other big tech and small tech companies today. So spurious correlation especially becomes important when you have a lot of variables to choose from as your predictors. You will always find some variable that statistically is very influential. But in fact, if it's not causality, you should avoid using it for prediction. And that's where we're just opening up our eyes to understanding not every data variable will be good for prediction, even if it shows good correlation.
It's interesting. So if you have data set with a lot of predictors and you increase data set size, you have a lot more observations, it will take a lot longer to train your model. So finding the minimum number of predictors which really have significant variance and will affect accuracy of your modeling, finding the right number of predictors.
Yes.
Okay. And sufficient data set size to predict correctly, increase accuracy of predictions, at the same time reduce time because trade-offs. Okay.
Yes.
I think this is very, very, very serious problem for everybody who try to do artificial intelligence. So
exactly.
what do you see direction in? What kind of things you expect to address this type of problems?
I think that now that we have plenty of data to choose from, plenty of variables and predictors to
Right.
choose from to predict or to make decisions based on the predictions,
Right.
We will start spending more time analyzing causality of these variables. We used to think that if we have a lot of data, then at least one predictor will be useful, and that doesn't hurt to have a lot of data. In fact, there are experiments showing that using a lot of good predictors still reduces your quality of prediction. But we used to think that understanding that model is trained on the past, and it's not necessarily going to work in the future as well as it explained the past. But we used to think that that only happens because of the overfitting problem. Now we can add to this. It's a type of overfitting, but a different type that we usually looked at. It is a spurious correlation that we based our model on. It was not excluded by analyzing the causality before we train the model. We spend a lot of time and money and resources training it, and it seems like it's maybe working, but all of a sudden it stops predicting properly and gives us bad decisions as a result. That is something that needs to be done before we train the model, and we definitely have not paid enough attention to this problem in the past years.
So what I'm hearing, data preparation, cleansing data, okay, covering gaps, then finding the minimum number of predictors and size number of observations. This is, it used to be and still and will be very critical problems in order to find trade-offs between, let's say, model accuracy, which is very important, and time to train the model and run the model. Okay, so this is problem of optimization. Would you agree?
Exactly, right. Optimization that is based not on fitting the model, but on preparing the data, wrangling and analyzing the flow of data, all the things that come as a result of getting enormous amount of data.
So you have multiple criteria.
Exactly.
You have data accuracy, time to get the answer. Okay, what else? This is probably major criteria, yeah?
You have to monitor and manage the flow of data.
Okay.
I think that maybe different people will have different name for that, but I think that traditional role of data engineer in the business is changing or splitting into two. Data engineer will continue working on putting the infrastructure, organizing the storage of the data, connectivity, but then there is a data flow manager that becomes separate from data engineer. And the responsibility of data flow manager is working with the sources of data, selecting the sources, analyzing and monitoring the quality of data coming from this source. Speaking about IoT, your sensor is sending you information. You need to, in time, understand that this sensor is not working anymore and it stopped providing you with useful information. It provides you with misleading information as opposed to that. So data flow manager will redirect the flow of data in the right place in the storage, organize the consumption of this data, validation, wrangling, all these questions before any model can be fitted with this data, and analyzing the causality as well. It's also better to do it before the model is fitted.
Here, and the last question, okay, what do you think about the role of ML apps, AI apps in achieving higher, acceptance of AI, ML, and I type of applications?
This is exactly what we're discussing now, because once this role and the necessity of this work has been recognized, we started thinking as a community, we started thinking about how to organize this process. If before, even when we worked with big data, it was still a one-of type of tasks. We need to find one source, put it together, organize the consumption of it. That was a problem that did not require any new subject. So new subject like MLOps appears when we have to put this process on industrial base, because the new sources of data appear and grow with exponential rate, and we cannot do it manually, one of a kind process. So we have to put special technology, special rules special traditions and practices of how to automatically, or at least if not completely automatically, but at least in a standardized way, to organize the process of consumption of data by AI engine. And that's exactly what the definition of MLOps is.
So in summary, what are the biggest achievement we expect in the next several years in applying modeling to optimize business and IT decisions from your point of view? Major.
So I think it's going to be a combination of two things. One still will be exciting. The other will be less exciting. The less exciting will be everything that has been accumulated so far and will be accumulated in the future will become a boring industry. And it will change our world, right? We may have a robot listening to us and providing us with services running around the house in the next couple of years, and it will change our world. But in terms of development, it will have been already past, right? It will already have been developed. And so this transition from complete imagination and our dreams into reality will speed up and has been speeding up very significantly. So we will see that entering our everyday life, and because of that, we will get used to it and we'll stop thinking about it as a cool thing. But at the same time, the new ideas, they come exponentially quickly, and something that we cannot dream about now will make us excited in the next few years, I'm sure. So there will be plenty to talk about.
Yuri, thank you very much.
Thank you.